Welcome back to the Foundry by Forge College. If you've ever just stared at your screen, watching a perfectly good automation script suddenly fail and flash red, well, you're absolutely in the right place. In today's explainer, we're taking that sheer frustration of broken pipelines, and we're going to turn it into a highly organized, deeply satisfying engineering detective story. We're taking you from someone who just mashes rerun and crosses their fingers to a methodical investigator. Let's get right into it.
So, to give us a little context on where we're at, in our last lesson we hit point A. We successfully built this shiny new CI/CD pipeline, automated our Solana workflows, and honestly, it felt pretty great. But as we look ahead to point C, bringing the whole team in for collaborative workflows, we are currently sitting at point B. We really need to know exactly how to debug this system when things inevitably go wrong. Because look, before you invite the whole team into the house, you gotta know how to fix the plumbing when it leaks, right?
Here's our blueprint for today's investigation. We'll look at the broken pipeline problem, line up our 3 common suspects, and gather our evidence. From there, we'll engineer the fixes, file our debug report, and finally get back to those green lights. Starting off with Section 1, the broken pipeline problem. What happens when the shiny machine flashes red? We've literally all been there. You write the code, it works flawlessly on your laptop, you push to GitHub, and bam, red X. The build fails. It's just a universal pain for developers everywhere when a perfect automation suddenly decides to throw a tantrum. So the really crucial question we have to ask is, why is the pipeline red? It sounds super simple, but your mindset here is everything. Think of a failed pipeline like a highly complex broken machine on a factory floor. When it stops, an engineer doesn't just kick it, unplug it, and plug it back in hoping for a miracle. They isolate the components. They run tests. We have to stop hopeful restarting and start active investigating. And honestly, this right here is what separates amateur hour from professional engineering. The wrong way? Indiscriminate runner upgrades, tweaking random environment variables, blind guessing. It's just throwing spaghetti at the wall. But the right way is targeted local reproduction and meticulous log analysis. True engineers extract the exact exit codes. They treat the failure like a logical puzzle to be solved. We're hunting for the exact line of code or the exact missing file that caused the whole thing to crash. Moving to Section 2, the 3 common suspects. Let's line up the usual culprits. When you're transitioning to a team environment, most pipeline failures in Web3 and Solana aren't mysterious ghosts in the machine. They almost always boil down to 3 highly predictable offenders. Think of this like a mechanic's diagnostic manual. Look at the first one. A test job fails because of a missing binary. The likely root cause is an artifact path mismatch. The build stage saved your compiled program in one folder, but the test stage is looking somewhere else entirely. The fix? Just verify those upload and download paths. Then suspect number 2, dependency fetch timeout. This is almost always network flakiness. The internet's not perfect. Connections drop. The fix here is adding an exponential backoff. And suspect 3, CLI flag unknown. This just screams toolchain version mismatch. Your local machine might be running Solana CLI version 1.16, but the GitHub runner grabbed 1.14. The easy fix is to hard pin the Solana CLI version right in your workflow. All right, Section 3, gathering your evidence. It's time to reproduce and isolate. We know our suspects now, but in the engineering world, you can't arrest a suspect without cold, hard evidence. To get that, we need to jump into our repository and reproduce the crime scene without contaminating it. So here are your 3 golden rules. Number 1, reproduce locally. Please do not make a tiny change, push to GitHub, wait 5 minutes for the runner, watch it fail, and repeat. That loop will literally drain your sanity. Run it on your local machine first. Number 2, treat logs as the absolute authoritative signal. The logs do not lie. And number 3, apply conservative fixes first. Never make broad, sweeping changes to your infrastructure right out of the gate. Keep it small, fix the path, pin the version. So let's break down the tactical step-by-step procedure to isolate this failure. Step 1, check out the broken continuous integration branch locally. Step 2, run the build script manually. Capture the build logs and use the ls command to list out the artifacts so you see exactly what files were generated. Then step 3, once you've got a solid theory, create a disposable debug branch and push a single test commit. We want to capture those precious, time-stamped logs in the cloud without breaking the main branch for everybody else. Which brings us to Section 4, engineering the fixes. Time to apply some mechanical solutions.
Now that we have our evidence, we can apply those mechanical solutions. And I should mention, this methodical approach is exactly why other programs here at Forge College place such a massive emphasis on robust environment pinning. Doing it right from the start saves you these exact headaches as your project scales. But I want to highlight one of my absolute favorite concepts here: exponential backoff. It's a retry strategy where the wait time between attempts progressively doubles, like 2, then 4, then 8 seconds. Think of it like trying to get into a locked room. You don't just furiously pound on the door nonstop without pausing for breath. You knock politely, no answer. You wait 2 seconds, knock again. Still nothing? Wait 4 seconds, then 8. It allows transient network errors to gracefully recover, instead of just hammering the network until your script instantly fails. But the real trick is knowing when to stop knocking. In our bash retry wrapper script, we set the maximum attempts to exactly 5. We give the network 5 chances, waiting a bit longer each time. This lets the system recover from a momentary blip, but it completely prevents your build from hanging forever and chewing through all your CI runner minutes if that remote server is actually just totally down. Beyond fixing the network, let's quickly summarize the rest of the mechanical fixes. First off, use explicit upload and download paths between your pipeline jobs. Never rely on the defaults. Second, validate everything. Throw in simple commands like ls right before test runs to literally print the directory contents out. Seeing is believing, folks. If the artifact isn't there, the test is going to fail. And finally, hard code your toolchain versions. Pinning the exact Solana CLI version in your environment is usually the silver bullet for fixing those weird, unexplainable errors.
Moving on to Section 5, the debug report. Time to file the paperwork. Every good investigator files a report, right? That way the rest of the team knows exactly what happened, how you fixed it, and how to avoid it next time. When you're writing a professional report.md file, you don't just type fixed it and call it a day. You need to provide the exact commands used to reproduce the bug, paste in 2 to 3 minimal targeted lines from the log as your smoking gun, write a really clear root cause statement, and lastly, link the specific commit SHA that holds the fix. This proves to everyone that the failure was scientifically resolved, not just accidentally fixed by, kicking the machine. Finally, Section 6, green lights ahead. We are ready for team workflows. Once your fix is pushed, the report is filed, and your network calls are wrapped up in those exponential backoffs, you get to experience pretty much the best feeling in software development. Just a clean workflow log printing a beautiful green 12 passed, 0 failed. Now, I want to reflect on a core truth from our source material. Automations that worked once tend to fail unpredictably during team adoption. Keep in mind, debugging isn't a sign you did something wrong. It's just the required preparation for the beautiful chaos of multiple developers working together. You're hardening the system to withstand a team. So we'll leave you with this. Is your automation truly ready for the whole team? Thanks to the debugging framework we just walked through today, the answer is finally yes. You've isolated those logs, pinned the versions, and smoothed out the network spikes. I highly encourage you to head over to forge.college to continue your journey and master even more Web3 development topics just like this. Until next time, keep your logs clean, your paths explicit, and your pipelines beautifully green. Thanks for hanging out with me on this Explainer by Forge College.